Hi everyone, in this video we're going to be talking about mixtures of gases. Specifically, we're going to focus on partial pressures and how you can calculate them using mole fractions. So imagine you have a container and it's been filled with three different types of gases. So we have gas A, gas B, and gas C. That would be a mixture of gases. And these gases are going to be moving around and colliding with the walls of the container. Those collisions will produce some pressure, which I've called P total. And now this total pressure is made up of pressure from gas A, pressure from gas B, and pressure from gas C. So each gas is producing a portion of the total pressure. So we would call the pressure from gas A, the pressure from gas B, and the pressure from gas C the partial pressures. Now let's look back at our total pressure. If we wanted to find the total pressure for this system, we would just need to use our ideal gas law. So PV is equal to nRT. Then we would rearrange it for pressure, and that would give us this equation. And now the key variable here is the number of moles, because if we want to find the total pressure, we need to use the total moles, which would be the sum of the moles of gas A, the moles of gas B, and the moles of gas C. But what if we only wanted to find the partial pressure of gas A? Well, we can still use our ideal gas law, but in this case, the number of moles is only the number of moles for gas A. The exact same thing would apply if we want to find the partial pressure of gas B. We're still using our ideal gas law, but the number of moles is only the number of moles of gas B. And now I challenge you to write the equation for the partial pressure of gas C. Now you can use these equations to find the partial pressure, but there is a different way, and that way is using mole fractions. The mole fraction is the number of moles of one gas divided by the total number of moles of all the gases. And the reason we care about mole fractions is because we can use them to find the partial pressures. So if we wanted to find the partial pressure of gas A, we can use this equation, which says the partial pressure of gas A is equal to the mole fraction for gas A times the total pressure. And we can use the same equation for the other gases in the system. And now one last thing to point out about mole fractions is that the sum of all the mole fractions for each gas in the mixture is equal to 1. You can use this to make your life a little easier when you're solving for mole fractions. And now let's quickly summarize what we learned before jumping into a quick example. We learned that the total pressure for a mixture of gases is equal to the sum of all the partial pressures of those gases. We also learned that if we want to calculate the partial pressure for a gas, we can use mole fractions. And we can solve for mole fractions by taking the number of moles of one of the gases and dividing it by the number of moles of all the gases in the mixture. And now remember, how do you find the number of moles? Well, you can use this equation, which says the number of moles is equal to the mass of the gas divided by the gas's molecular weight. And of course, don't forget that you can use the ideal gas law to solve for the total pressure or partial pressures. So now using these equations, let's jump into a practice question. In this question, we have a 13-liter scuba diving tank, which contains 25 grams of helium and 4.5 grams of oxygen gas at a temperature of 298 kelvins. And we want to know what are the partial pressures of both gases and what's the total pressure. We know that P total is going to be the sum of the partial pressures. And we know we can calculate those partial pressures using these equations. And now in order to use those equations, we need to know the mole fractions. And so now I hope it's clear that the first thing you need to do is solve for the number of moles of helium and the number of moles of oxygen. To find the number of moles of helium gas, we just need to use this equation. So we take the mass of helium gas divided by helium's molecular weight, and that gives us 6.25 moles. Now let's find the moles of oxygen gas. We just take the mass of oxygen gas divided by the molecular weight, and that gives us 0.28 moles. Now in order to find the mole fraction, we also need the total number of moles, which means all we need to do is add up the number of moles of helium gas plus the number of moles of oxygen gas. And that gives us a total of 6.53 moles. And now we have everything we need to find the mole fractions. We'll start by finding the mole fraction of helium. That would just be the number of moles of helium gas divided by the total number of moles. And when we do the math, that gets us 0.957. Now let's find the mole fraction for oxygen gas. That would just be the number of moles of oxygen gas divided by the total number of moles. And when we do the math, that gets us 0.043. All right, now that we have the molar fractions, we're almost ready to solve for the partial pressures. But first, we need to figure out the total pressure. To do that, we can use the ideal gas law, because we know P total is going to be equal to nRT divided by V, where N is the total number of moles. And we've already calculated for the total number of moles. So all we need to do is plug in our values for the number of moles, the gas constant, the temperature, and the volume. And when we do that, we can see that the total pressure is about 1,245 kilopascals. And now that we have the total pressure and we've solved for each mole fraction, it's time to solve for the partial pressures of helium and oxygen. Starting with helium. We can find the partial pressure of helium by using this equation. All we need to do is multiply our mole fraction for helium times the total pressure. And that gets us a partial pressure of 1,191 kilopascals. Now let's solve for oxygen. If we want to find the partial pressure of oxygen gas, we can use this equation. All we need to do is multiply the mole fraction of oxygen gas times the total pressure, and that gets us 54 kilopascals. And now with that, that's the end of this question. We solved for the partial pressures of helium and oxygen and the total pressure of the system. And that's the end of this lesson on mixtures of gases, partial pressures, and mole fractions. Thanks for listening.